Hello everyone. In this video, I want to show you an example of a back titration question and also explain to you when do we use back titration versus a regular titration question. So using a normal titration, we can always find the information of an analyte using a titrant. For example, let's say if we have a solution of HCl that we don't know the concentration of. So the concentration is the question mark, but we know, of course, how much volume we are using. We can titrate it with NaOH because we know NaOH is a base and HCl is an acid, so they can neutralize each other. So we can titrate it with a known concentration of NaOH. So of course we know how much molarity of NaOH we have. And then using an indicator, we can know when to stop adding NaOH so that they are both neutralized. They're both completely neutralized with each other. So this way, after the neutralization happens, we know how much volume of NaOH is used. So then by writing the reaction between HCl and NaOH, which is a acid-base neutralization, we know we make water and NaCl. So we can find the information of HCl. So here we know the molarity of this. So this is known, check mark. Volume of this is known, check mark. The volume of HCl is known, check mark, but the question mark is the molarity of HCl. So to answer and to solve for the concentration of HCl, first we have to find the number of moles of NaOH. And we know that moles is always concentration times volume. So we first, by multiplying these two numbers, we can find the number of moles of NaOH. Then using the stoichiometry and the balanced equation, we see that the ratio between them is a 1-to-1 ratio based on moles. So we know whatever moles of NaOH we have, the number of moles of HCl would be the same. And then this way we find moles of HCl. Eventually, we can find the concentration of HCl by dividing its moles by the volume of HCl, and this would be our concentration of HCl. So this is how a normal titration works, and it's pretty easy, one reaction, and it takes place exactly as I'm showing. Usually it's done during using a titration in this setup. By the way, HCl in this case is considered as an analyte because that's the one you're analyzing. That's the one that it has an unknown concentration. So we're trying to find its concentration. And then the thing that it's being, the substance that's being added from the top using a burette is considered as a titrant. So you're using it for the titration in order to find the concentration of the analyte. So this is the normal titration. However, sometimes a direct titration is not possible. It's either because the analyte is insoluble or the reaction between them is very slow. So in those cases, then they have to use a back titration instead. So back titration generally involves two reactions, not just one. It's actually two reactions back to back. So I'll show you how that works. And this is a good example of that. So I'll show you by making a little setup, the drawing of what's happening over here. So let's say here what they're trying to do is they want to find how much active ingredients of magnesium hydroxide is inside a 1.24 grams antacid tablet. So let's say there's a tablet of antacid with 1.24 grams of the tablet that contains MgOH2 and other things. So it's not just MgOH2. Therefore, it's not a pure substance based on MgOH2. It has other things in it too. So what they're doing is first, they're dissolving it or reacting it with a sample of H2SO4. So how much H2SO4 are they using for doing this? It's 50 milliliters, and the concentration is 0.1 molar. However, the thing is, the way back titration works is that something like H2SO4 that it's used here has to be in excess. So in excess means, if you remember from limiting in excess, reactants, always the limiting reactant is the one that it's completely used, but the excess will always have some leftovers. So what happens here is that MgOH2 will react with H2SO4, and the entire MgOH2 will get neutralized by H2SO4. So together they will make MgSO4 plus 2H2O. However, because H2SO4 is in excess, it will have some leftovers. So next step is that the leftover, now it's going to do another reaction for us. So we're going to carry a second reaction. So let's call this reaction 1 and call this reaction 2. So H2SO4 will carry a second reaction with, in this case, NaOH. So it's actually being titrated with NaOH. So they will react together. Let me put this here, NaOH. So they will react together. Together they will neutralize again. So giving us 2H2O and Na2SO4. And then basically from the information of NaOH that we used, we can see how much H2SO4 was left over. So in these types of questions, we're kind of working backwards. So let me put numbers down so we can see what we're doing exactly. So here, the volume of NaOH used for the second titration was this many milliliters. The concentration was 0.1133 molar. So first thing is, by multiplying the volume and concentration of NaOH, we can find how much NaOH was actually used in the second reaction. So we just multiply these two numbers, and that would tell us that 2.36 times 10 to the negative 3 moles of NaOH was used in the second reaction. After that, we can do the stoichiometry using the balanced equation between them and seeing the ratios between the moles. So we see there's a 2-to-1 ratio between the moles of both of them. So this way we can find the number of moles of H2SO4, which is essentially dividing this number by 2, the number of moles of NaOH by 2. So that would give us 1.18 times 10 to the negative 3 moles of H2SO4. However, this mole, keep in mind, it's not the total number of moles of H2SO4, because this is the total number of moles of H2SO4 we had. This is going to be the moles of H2SO4 left over after the first reaction was done. So essentially, by subtracting the total number of moles of H2SO4 we had in the original container minus whatever was left over, we can see how much H2SO4 was actually used in the first reaction. So I'm going to do that right now. So here, in terms of moles, let me use another color. We had, by multiplying these two numbers again, after the volume is in liters, we see that there was 5.00 times 10 to the negative 3 moles of H2SO4 was the total amount of moles of H2SO4 in the container. So by subtracting that number minus the number of moles of H2SO4 left over from the first reaction, we can see how much H2SO4 was actually used in the first reaction, which gives us 3.82 times 10 to the negative 3 moles of H2SO4 was used in reaction 1. So this is the moles here, 3.82 times 10 to the negative 3 moles. Now, the question is, we want to find the percentage by mass of MgOH2 in that sample. So the percentage by mass of MgOH2 is the question mark. So to do that, we have to see how much MgOH2 was actually used in the first reaction. So what we do is we go backwards, again, doing a mole-to-mole ratio between them, and we realize that 3.82 times 10 to the negative 3 moles of MgOH2 was used in the sample. So that's technically the pure amount of MgOH2 inside the entire antacid tablet. So we can convert that to grams. So we know for every 1 mole of MgOH2, the molar mass is 58.3 grams. So we know that 0.223 grams of pure MgOH2 was in the tablet. Now, to find the percentage of MgOH2 in that tablet, it's essentially like a percent purity question. So it's basically the grams of pure MgOH2 over grams total, which is the mass of the antacid, times 100. So technically the percentage of MgOH2 is 0.223 grams over the mass of antacid tablet, which is 1.2 grams, times 100, which gives us 18%, 18.0%. And yeah, this is how we find the percentage of MgOH2 inside the antacid tablet. So again, keep in mind, for a back titration question, there's 2 reactions taking place. In the first reaction, definitely your acid in this case is going to be in excess and it will have some leftovers. So later, with the help of a titration afterwards, which is with NaOH, you're basically finding out how much H2SO4 was left over. Then from the leftover and the original amount of H2SO4, you can figure out how much moles of H2SO4 was actually used in the first reaction. And that way you can find anything you want, like the percentage purity, the molar mass, sorry, the molecular formula or empirical formula or whatever they're asking for the first substance, which is MgOH2. In this case, we're finding the percentage purity of MgOH2. All right, so that was it for this video. I hope you enjoyed it. If you did, please make sure to like it and subscribe for watching more videos. And if you want me to make you some videos of any other topics, please leave me a message. Thank you.